Welcome to the components of cryptocurrency part 2. Here we will study what is a blockchain. Blockchain is a technology that runs cryptocurrencies. Blockchain enables an open distributed ledger that can record transactions between two parties efficiently and in a variable and permanent way. Ledger, Finnish, tilikirja, reskontra. Basically, it is a way to keep track of money transactions. Next, we will go over this blockchain that is depicted in the figure you can see in the slide. We will start from transaction root, TX_root, that you can find in each of the blocks 10, 11, and 12 on the lower left corner. In block 11, you see that TX root has been opened up and expanded. In the transaction root in block 11, if we look into the lead nodes that are transactions TX0, TX1, TX2, and TX3, they are at the very bottom, and they are the transactions. They are hashed into hashes, hash 0, hash 1, hash 2, and hash 3. Transaction hash values are again hashed, so that hash 0 and hash 1 are hashed again to form hash 01. Similarly, hash 2 and hash 3 are hashed again to form hash 23. These hash values make transactions difficult or nearly impossible to alter. In all blocks 10, 11, and 12, you can see timestamp, which marks the time when transactions were processed. Similarly, you can also find nonce, N-O-N-C-E. This is a random number which is searched for each block in the Bitcoin's proof of work system. In all blocks 10, 11, and 12, you can see the previous hash. This is the hash value of the previous block. It links all values together and therefore forms a chain of blocks. As you have seen, hash functions are everywhere in the blockchain system. But what are those hash functions really? Let's have a look. Hash functions take in data and they compute fixed length output. Even small modifications of input results in large changes in the output hash. We will later try this on the website onlinemd5.com. Hash functions are one way. This is very important as it means that brute force attack is needed in reversing. In reversing we mean what input generates a particular hash. Since input space is infinite, in other words, it's larger than the output space, there are collisions in the hash functions. These collisions mean that two inputs generate the same hash. However, they are very rare. In hash function SHA-256, this happens every 2 to the power of 256 hash values. Hash values are also used as checksums, as you can see in the lower right, where different files, Mist Linux Debian and Mist Linux zip, are provided for download, but also it is given what their hash value SH256 is. Using this hash value, the downloader, once he or she has downloaded the file, can verify that they have received the correct file and no alterations have been performed. Hello, now we are in the website onlinemd5.com. where you can generate hash functions for free. And let's try this out first. Let's generate some message to the screen. And this is our data. So in previous we said that hash functions take in data. So let's generate some data, and I will type in a sentence, Bitcoin rules, like this. Now, what was previously said, that even small modifications in the input result in large modifications in the output. So let's try this. Let's add a spelling mistake to the Bitcoin rules sentence. Pay attention to the hash, the string hash here in below, and see how it changes when I remove this S. As you can see, it is now totally different. It is also very difficult to generate a particular hash. Let's say that in the string hash field, we wish to have a hash that starts with 3 zeros. We'll just start entering more letters and see if we can find even a 1 0. So let's try. 1. Now I'm beginning to wonder whether it's even possible to get to 0 to the beginning, but let's continue. Oh, there was a 0. Take 1 back. There we have it. Now we have the 0 in the beginning. This is simply to demonstrate how difficult it is to produce an input that would generate a desired string hash as an output.